if we look where we come from before actually jumping into promises, that will give us like an example to work on throughout the session. So prior to having promises in JavaScript, what was being used mainly was callbacks. And if we look at this screen full of crap, let's put it that way, let's try to follow this and see where the problems are. So we see line 10, we create a function that takes a DB and have a callback. Okay, fair enough. Line 15, same deal. Get data. I'm guessing it gets some data. It has a key, a DB, and then a callback. Fair enough. Process data. It takes data and has a callback. Okay, that's fair enough. So that's your interface. You take it, you use it, and then you start writing an app with this. Let's put it that way. Line 29, app starting, fair enough, and then 31, connect to a DB, my awesome DB, takes a lambda, like we've seen in the last session, which is basically an unknown function in JavaScript. Go into there, create a local variable, and then call getData, which call getData with key. We remember line 15 that the key is the first one. We pass the DB, and then we have another lambda that takes D, which is the data. And then we call process data. And then we get some args. That's our passed in. And then we call console log, and we assign those args into data. So line 41, and that's the question, what will be printed out to the console?
Data will be empty.
Exactly. And then now everyone is scratching their head, or at least like anyone that has written this code is just like, why is my data empty? What's going on? What is this? And this all comes down to the biggest problem of this code, which is there is tons of scopes and closure that isn't dealt with in there. So if we execute the code, it actually works, but working is a good word, but it does something. So what we see is that it starts the app, and then that's the data undefined, like Shane just said, and then yay, I'm done, and then return some value. So if we look into those, those functions, basically connect to a DB takes a callback, put a set timeout on it, call that callback with what you've passed in. Get data does the same thing except that it returns a random word. And process data creates an array of random words and wait for random time and then call that callback. So we end up in there with this data equal args, which in the end will never be used anywhere because that data actually is, that scope already has exited. And so this brings us to one of, this is one big problem with callbacks. It's the fact that you play with scopes and you create function inside a function inside a function inside a function, which in the end you have no clue. I mean, it's possible to have a clue, but you're not sure which scope and which version of the closure you're going to have. And add to this the fact that instead of being a string, data could be an object. For an example, then if it's an object, it's passed by reference everywhere, and then you start modifying an object that comes from somewhere that's, you have no clue what's going on really. And so to add to this, the whole promises thing was created because, for an example, process data could actually call another function that calls a callback and that calls a callback, and then you end up with this big giant tree of callback, all indented, and it's exactly what I said. It's what I call callback hell. You're in one point where you don't have any clue of what's going on anymore. So promises came along. I do not have a story on promises, and I don't intend to make this in a story course. But they are vastly better, and that's the end of it. Let's see what actually is promises now. So what are promises? This is coming out of Wikipedia. I think promises represent the eventual result of an asynchronous sync operation. It is a placeholder into which the successful value or the reason of failure will materialize. That's exactly what a promises is. exactly when I was speaking functional programming the other day. It's basically instead of thinking about the steps on how to call a callback, you actually think about what should happen. So let's see some example. We will look at that PNG later on, but let's see some example first. So I created two functions, two simple functions, do successfully something and fail something, which basically in both cases just either return a promise that is successful or return or like fail a promise. Let's look at example 8 for an example. So what the promise is that it's an object that has a then and a catch method on it. That object represents exactly what it was said. That object represents something that will at some point actually be resolved. So, for example, do successfully something will be called with a string, and then we'll call that result, and then that console.log will be there. So if we were to execute that example, a very, very simple example, it's going to basically, like, simple example, that's the first two lines, it's going to console out a string. And so, okay, there's a lot to digest in this, but basically the whole point here is that when you have a promise in your hand, you can always think of it as something that you can change stuff over it. So, for an example, you have a promise, and that promise, you want to do something after that promise. So you just do a dot then create a function, and then do something in there. And then if we will go through all the simple examples, and I'm going to actually start saying why this it makes sense, because right now this looks more complex than actually using callbacks. So a promise can, like I said, either successfully resolve or fail. This is an example of the failures. If we call fail something, which return you a promise that fails, let's take it at this for now. The .then method takes two callback or two methods. It calls the success, and then if you add it, comma, the error. The error is optional, and we will see why in C, which is line 46. You can instead put a catch on a promise. So if you do promise.catch, it's going to basically just add an error catcher, and it's going to call the error there. Okay, so simple failing example here. We basically get error and error and error and error, which is basically the same string. Bad design on my part of those examples, but whatever. So from at this point, what we know is that the promise can be done, and a promise can catch some errors. The next step of a promise is the fact that the promise will always return a promise. So that's how we made them chainable, is the fact that with a then, a catch, or any other function on promises will always return promises. And so what you can do is, for an example, do successfully something A, .then result, console.log result. This is going to shoot echo hey, which we have here. And then you can return B, and then B will be passed to the next promise, which will log B. And then C here is basically just abandoned there. So that's the other thing, and then a promise can also return a promise. So that's the last part of this whole thing to make it useful, is that you can actually return a promise, and if you return a promise, it's going to actually resolve that promise before continuing on that chain. And the result of the inner promise is going to be passed to the next callback. And so if we look at E, which is kind of the last example, do successfully something A, result, log, and then we return a promise here instead of actually returning a value. That promise, it's just a set timeout that's going to basically wait for 1 second. It calls the resolve function, and then calls it for wait for 1 second, and then will call here afterwards. And so that's the last example. So we have A, we have a promise. Okay, so now that's this one. So I'm sorry. A promise can return a promise. This log B, for some reason, yeah, the problem I have here is that the chain because promises return promises, so that's one error here. I am sorry about that. But if we just execute E in that specific case and see what happens, that's more like it. So a promise can return a promise. I waited 1 second, and then this actually is the log from here, and that C will never be outputted because it's not, there's nothing that actually catch it. We could, on the other hand, for an example, add a dot then here because that was a problem. So we need to return it, that function. So, and then if we do a dot then, and then string as in console.log string, we will see that it's going to actually output C, which is the result of here. Okay. So these are the basic use case. The thing I've jumped over that we will see here is how to create a promise. So yes, we can use a promise. Promise as .then, as .catch. You can actually do stuff with it. That's all good, but we need to create them at some point. You need to create the first promise. Let's put it that way. There's a promise constructor that looks like this, which is basically you call new promise, and then you pass in a function which will have 2 arguments, resolve and reject. You call eventually resolve with the result or reject with the result. It's up to you. You can also throw, and it's going to actually be catch as a reject, so it won't actually percolate up until the top layer and actually crash the app. So if instead of rejecting here, if we would do throw str, this would actually work. So if we were to use something that was failing C, for an example, this will actually like an error, and it actually comes out from the throw. So you can actually either call reject or you can throw to actually get this. So what can you do with promises, basically? If we, for an example, promisify the step 1, it would look like this. So let's forget the whole promises thing and look at the end of the file. Usually when you use promises, your code would look like this. So you will have something that will generate you your initial promises, and then you will do .then on the next one, and .then on the next one, and .then on the next one. So for an example, this whole code, which was hard to follow, turns out to be quite simple with promises. So you call connect to a DB, which returns you a promise that when you will be connected, it's going to be resolved. And then you call get data on that DB with your key, and then you call process data on those keys, and then with the keys that are returned, you basically log them. And if we look at we could execute it for the fun of it, and then we will see app starting. Since there's timeout everywhere, it does all its steps and end up calling line 23. Yay, I'm done. And then basically return you, the array of, words. Yeah, so that's how, the design of, the usual design of promisified stuff will go that way. So you create a promise, you do stuff with it, and then you go forward, and then you next, and you try to keep every step as simple as possible. And that's where I find promises interesting, because promises are kind of the first step into today's world, into functional programming, because in the end, with promises, it's quite easy to actually have, I would say, somewhat pure functions, so function that actually only takes arguments from the input and do stuff with it. It's not the true definition of pure function, but whatever. The idea is that you can actually minimize easily the side effect. So like with promises, you rarely need to use local variable to do something, for an example, and you just go for it with one to the next, to the next, to the next, to the next. If we could look at how ConnectDB was done, it's like the promise constructor with resolve function, and then we call resolve instead of calling the callback. Get data would be the same. Process data is more or less the same, and basically we end up with that promise chain. The hardest part to understand about promises is this. It's how to handle exception, or I'm saying exception, but not really an actual exception, more than a failure case. Let's jump the same data here we have. So line 5 do successfully something, line 11 fail something, and 17 I created a small function that console log what you pass in as the first argument, and then that basically return the next promise. So the idea is just to actually play around with stuff. And so we've got A. So let's take a peek at A to start. A will do successfully something, and then have this callback, which will basically end up calling what's the result, and then call the next function, or not call, but actually promise the next function, then the next function. So, and then this is a successful, and then if you were to fail something in a promise chain, it's gonna jump, and that's what the arrow are meaning, to the actual next catch in line. So in this specific case in A, what will happen is that it's gonna actually go to line 24, line 25, and then all this will get trashed out because there's no error handler in there. And then at line 29, the catch is there. And that's the part where people get confused, is that if the catch actually successfully parse the error, the promise chain can then continue on. And so as soon as you've got catch, you will get, in this specific case, we will get failure tree that's going to be printed out, and then do successfully something will continue on, and the resulting promise is a fulfilled promise. Is that the right? It's a settled promise. I'm sorry. So what I mean by that is the fact that if that catch can actually handle the whole error, there's no reason why you couldn't continue on that. There's no reason you can continue on that actual promise chain. And so, for an example, line 30 will be executed, and we will get success 4. But line 26 through 28 will never get executed at all. That's the idea. So it's going to basically be, that's the first time it's going to fail. And so the idea, and if we look at B at that point, so the idea is that you do successfully something, you fail, and then you get to the error handler of your fail, and then you cannot do anything with it. So you're just like, well, yes, it has failed, no, nothing else can execute. I'm going to give you an example. Like I've got this string parser. I expected to have 2 IDs in there. There's only one. I cannot actually recuperate from this. I need to actually crash the program, or to go up. And so what happens is that you actually, for an example, just fail something again. And usually what you use your catch for is to supplement your error with other thing. So I'm sorry about that. So for an example, you are in a flow, you log into something, and then that login fails for some reason. You're in the context of the login, you know everything about the login, and so you can actually create an error, an object that will make sense for the upper layer to have to actually log something that makes sense. I'm going to give you an example of this, but basically, like example B is what I've been saying, which is, you've got, it will jump from line 36 to line 40, and since line 40 actually fails to, it basically go back into the error mode, and it's going to jump over 41, 42, and then it will end up at 43. And 43 doesn't actually, like fail or success something, meaning that it's a success, meaning that it's a resolved promise. You could actually go on and continue with this, and having no problem with that. And so that's the part about promises that can be confusing at first, because you're like, and if we look at the example, let me separate them, though it can be easier to follow. Save, and then come on. Loop. So for the example of A, like I was saying, success 1, success 2, failure 3. Failure 3 is actually printed here, and then success 4 because it's actually a promise that is successful. Here we are, example B. There we go. And then we have success 1, success 2, because these two lines will work. And then the failure is going to happen, failure 3, and then failure 4. So let's go further. So promises will obviously comes with a paradigm change, in a sense that more actually, callback did it in a sense that they asynced stuff while, like hiding it under callbacks, and people were thinking they were synchronous because they are, and that's the problem we had in the first example, which is, if you think that this is synchronous, data which was extracted and was in another context would be, there yet it's not there yet. And that's one problem. When you actually design with promises, it tries to go a touch further, while ensuring that you don't do that kind of stuff, because every function is separate. It doesn't mean you cannot do it. That's not what I'm saying. I'm just saying that if you take a step back and you change how you code to code with promises instead of coding with half promises, half callback, and everything is mixed up, you can end up with code that's easier to read and easier to understand. Promises will expose two methods to actually help what you've been saying. So you can do, if you do promise.resolve A1, for example, this will return a promise that is already resolved with 1. And so if you don't want to go through the new promise with the executor, you can do this. So if you do promise resolve, and then you use .then, and then you can basically start doing stuff here, and then you return 1. This is as valid, and this will return a promise that's as valid as the other one we would create using new promise, and then resolve, and then resolve 1. So that's basically equivalent. And where are those two ones? So promise, resolve, promise, reject are useful is that when you're not dealing with synchronous stuff and you don't actually want to create this whole object for nothing, basically, you can actually make function return promise.resolve or promise.reject, and basically go on with this and use them for that. And that's something you can do. There's two other calls on promises that I find very useful, but we get into data processing more, like the world of data processing. So promise.all and promise.race. Okay, so let's. I have time. So promise.all is basically takes an array in, returns you a promise that will resolve as soon as all of the promises in the array are resolved. So let's make an example. It's going to be easier. So let A equal, and then 1, and then okay. So we've got this array of stuff. We want to actually process this stuff. Let's say that's a number, but it could be anything else, and it could be something that goes to the network. So no, let's try to get all this in the DB. So these are keys, for an example. So that's a better example. So these are keys that you need to get into the DB. Okay. What you can do with this is you want to basically take each and every key, create a promise against it, and then you want to call promise.all on it and basically forget about this. So let's do this. So we do a map on this. So this will return you promises. We do a map of keys, and then we have our key, and then we like get key. So return get key of k, and then this. So let's like in this specific case, get key function get key takes a key in and return promise.resolve key. So that's the dummy example. This could actually be a DB call. So you could call mongo.get or like redis.get or whatever you want. So you have in your hand a bunch of promises. So this will basically look like this in the end. And that's going to be get key 1, and then place with paste, and that's basically going to be this. And so the idea is these in fact won't be this really. It's going to be the promise that gets out from that. But like it happens sometimes that you actually want to have. You don't care how they are called. You just care that they are all called and all resolved before you actually want to do something. And so what you can do is promise.all, and then on promises, and then the .then. And then results here will be the result of each and every key. So it's going to return you an array of each and every promise that's going to be basically what you are interested in. And so result in that specific case, results will be an array of like result 1, result 2, result 3, and so forth. And so that's how you actually, if you have data processing to do on multiple keys and you don't care how they are actually done and in which order they are done, because promise.all doesn't guarantee the order. It's going to basically, but they guarantee that the resulting array will be in the order than the resulting input will be. So it's possible to actually play with this. And promise.all return you a promise, so you can actually, you do stuff, and then you end up in a place where you actually need to do 10 promises, for example. You pack them into an array, and then you basically split them to promise.all. It gives you a promise that will be resolved only when all the promises will be resolved. Promise.all fail fast, meaning that it's going to fail as soon as the first one will fail. So if, for an example, get key 3 failed because the key doesn't exist yet, get key 4 and 5 didn't, weren't even done yet, it's gonna fail and kill all the promises at the same time. Promise.race is the opposite of this. Erase is a bad name for it. It could be a promise.any would be a better name for people that know the difference between all, and any. Promise.race, I've never actually seen a way where I could actually use this somewhere, but it exists, so I'm basically mentioning it. Promise.race basically will take all the array of promises and will actually try to execute them all at once, like all, and will return as soon as the first promises to return returns, and gonna kill the rest. So the idea would be, you have a server, you want to connect to another server, you want to connect to that server on a specific port range, so from 8,000 to 9,000. You can create yourself an array of promises that creates a connection on each and every port. And basically, as soon as one has returned, the rest you don't care about. And so all the rest basically will get discarded, and you will get only one result on promise.race. That's the example Don had for me when I actually asked where this could actually be useful. And yeah, that's promise.race. It fails slow in the sense that it's going to wait until every and each of them have failed to actually return you a promise.fail, because it goes by the intention that it's possible for one out of the 1,000 you gave it can still return true, or not true, but a value in that case, and not fail. So that's promise.all and .race. All can be very useful in that thing where you actually create tons of promise and you want all of them to be resolved. I've used that tons of time in what I'm writing right now. And promise.next would be an example. It's not an actual method of promise, but promise.all don't guarantee you the order in which the promises will be executed. And so something you could do if you want to make sure that they are executed one after the other is a reduce, and that's the last thing I'm going to leave you on. If you reduce the promise array and you have your promise and the next one, what you can do is that you can do promise.then next, and you start the whole thing with a promise.resolve. And so the idea is that what this will do is the short form, and this give you and promise, at the end. So what this will do is basically, call get key one dot then get key two dot then get key, and so forth, and until it ends up, it's in this specific case it's get key, but it could be anything, any promises. And so the idea is that this will actually guarantee you that one will be called before two, will be called before three, will be called before four, will be called before five, and that's something that isn't implemented in the promise framework, but it's kind of easy to implement with reduce.